All right.
Hi, everybody. Welcome to the SIG Auth meeting for October 18th, 2017. Today we have a few pulls of note, one design of note, nothing in the discussion section, so maybe it'll be a short one. If anybody has anything they want to drop in the meeting notes, please do that. First up, we have Matt Moyer of Heptio talking about the AWS IMA webhook authenticator. Matt, do you want to share your screen or just sort of chat about it?
I just wanted to give a quick mention. This is like a new kind of experimental kind of tech demo of using AWS IAM to authenticate to a cluster. So there's sort of two use cases I see for this potentially. One is like for sort of bootstrap administrative access to a cluster in AWS, where you kind of bring the thing up and then instead of having to kind of smuggle an initial admin credential out of there, you just can sort of authenticate through an admin role in IAM. The other use case potentially is for node bootstrapping. So through this kind of mechanism, you can get a token that encodes instance ID and account number. You can then look that up into the EC2 API and translate that into sort of a bootstrap identity for a kubelet, potentially sort of instead of the existing bootstrap token system, for some use cases. So anyway, this is sort of an experimental thing. If you have any comments, it's welcome. This is not like a Heptio project exactly, so feel free to if you have ideas for directions this should go, let me know.
Was there any direct feedback you have for sort of experience of building a webhook authenticator? Is that properly documented, or can we sort of improve anything on that end?
Yeah, that was reasonably smooth. I ended up pulling in the world in terms of dependencies just to get the subject review type, which is like a little annoying. And then the sort of deployment mechanism I ended up doing for this is to run it as a daemon set and have it generate its own kubeconfig that then drops down into a host mount directory. So it's sort of like you run the daemon set, runs on each master node, self-signs a CA for itself the first time it runs, generates the webhook kubeconfig, splits it down on disk, and then you have to go sort of update your API server with that webhook flag, which actually I think works out reasonably well in terms of ease of use. I still would love to see, there's an open issue maybe we could discuss about self-hosting sort of webhook authorizers, authenticators, and audit, and sort of pushing some of those things to dynamic configuration, component config.
I know that some of the feedback there was that there were clear use cases around authorization, but not necessarily authentication or audit. So probably would be good to hop into that thread, and if you have a clear use case, then be commenting there.
Sure.
Looks like we don't have any demos today, so the next item is the pulls of note. First, there was a PR for allowing authorizers to return unequivocal denies. So this would allow for instance, a webhook authorizer to say, I don't care what RBAC says or any other authorizer in the system says, do not allow this action, basically no matter what. I saw that it was updated recently. I don't know if there's specific outstanding concerns there. I don't know if, I think that was Mike Denise. You had that open if anybody wants to comment on that.
Yeah, I'm not sure who added it to the agenda today. I think we talked about it on last agenda, or maybe I put it on the wrong date. I think we talked about it last meeting, but it has been updated. So if you guys get a chance to review it again, I have addressed all comments.
Yeah, I was out of town for the last meeting, so I just put it on there.
All right, sounds good. Yeah, so let me know if you have any questions. We discussed it vaguely in principle at the last SIG meeting or 2 SIG meetings ago, and kind of decided that it was reasonable. So please go take a look at the implementation if you're interested.
Okay. The next item is that there was a PR for aggregated RBAC roles that was put up by David Eads. I know that that was to address some of the concerns around some of the inability to add additional policies or permissions to the existing default roles. It looks like that has some good conversation, and from what I saw, it looked pretty reasonable. I don't know if anybody else had additional comments on that. My one question, I don't know if David was here, that I asked in the PR was whether we see sort of the default, the view, edit, and admin roles switching to this capability in the future.
Yeah, so I do see them switching. I actually think I see them switching in 1.9. I'm going through the migration impact, and there's both a doc and a code pull, depending on how you like to review. But the code pull shows how reconciliation would happen. I think the only outstanding question about migration is if someone has already edited these roles, are we going to create a synthetic role for them to aggregate in? I am fine with doing that. It would just be one more bit of code that we would be hanging on to. Otherwise, I think the only comments I've seen in the doc have been largely positive, and in the code have been around how you do the particulars of reconciliation.
Yeah, as more people are defining CRDs, I'm actually surprised we haven't gotten the question more often. How do I contribute to these default user-facing tools?
Oh, they're all cluster admins in their namespace, I'm sure.
Yeah, I'm pretending that that's not why we haven't been getting those questions. But yeah, if you look at the design, that lays out pretty clearly how nice this is for having a single manifest that can set up your CRD and your contributing roles. Or if you're doing an aggregation API server, you can define your deployment and your service and your API service and your role contributions. And it's one manifest, and it's pretty awesome. Then you can remove all of those things, and they all just go away and get ripped out.
Awesome. Yeah, I think David, thank you also for just opening the docs PR as well. Sometimes those are easier to review than code ones. The last item I had on here was the self-subject review support for the webhook authorizer. This seemed pretty uncontentious, but just wanted to drop it in here since it was one of the things that was net new from the last meeting. Since there are no more proposals of note, we'll move on to designs of note. The last item on our agenda today is Mike Denise's trustworthy workload JWTs doc or proposal. It has since gotten to V2, I guess. Mike, I don't know if you want to talk a little bit about that.
Yeah, I have. So the V2 proposes a single issuer model that is a bit different than the issuer models in the original doc. Have people gotten a chance to read the new issuer model?
Maybe just if you could summarize it really quick.
Essentially, it gets away from some of the issues with the centralized model, brings the decentralized model closer to a standard validation practice. It uses a proof of possession key semantics to bind JOTs, usage of JOTs to key pairs that the workload holds. And for this reason, I think we can feel more comfortable for making the long-lived, the JOTs issued by the central authority more long-lived. So in this model, the central authority would build a JOT valid for 48 hours that confirms a specific asymmetric key that the workload holds. The workload would present that JOT to external integrators and prove possession of the key through some mechanism. This is RFC 7800, JOT proof of possession key semantics for JWTs. And I think a lot of people might ask themselves, this starts to look very similar to X509 certificate chains and spiffy client auth TLS validation. I think a notable difference from a security perspective between this is that it allows for propagation of end user credentials into API layers. So notably, if you have a large service that provides that you provide some product offering to many tenants, you might not want to take what your front ends, like your Nginx's, say for granted. So if you terminate TLS at the Nginx layer, you're not going to be able to propagate an end user credential into an API such that it is validatable. So this is a noted advantage of the JOT model that provides very similar security semantics to TLS and also availability semantics.
Mike, could you repeat that and go into a little bit more detail? I'm not sure I caught the subtleties there.
Suppose you have in a system that you trust one system in your entire company to assert identities. Client TLS works really well. Mutual TLS works very well just for service-to-service communications. It does not work well when you want an end-user credential to propagate into many layers of an API. So if you have a user that, say you are AWS and you have, or Google Cloud, and you have a user that authenticates using X509, you kind of delegate, you kind of trust implicitly your front end, which are exposed to the world.
Okay, so let me put this in critical terms. So like I log in, to Gmail, Google as joebita@gmail.com.
Right.
And maybe there's the Google front end, then that like authenticates that session cookie for the browser. And then it tells, say, maybe the Gmail front end, hey, this is joebita@gmail.com. And then that thing then goes ahead and tells the back end, hey, this is joebita@gmail.com. And there's no sort of like strong assertion from the guy who authenticated it all the way down the stack. Is that the idea?
There's no validatable assertion.
Yeah, okay.
You can make an assertion that this came from the front, that the front end said this was this user, but it's not validatable by the deep back end.
I think it's a valid use case to consider that like mutual TLS does not survive ingress or egress in most environments. Like the ingress case is like the one you're talking about, where you have some set of like load balancing tiers that terminate TLS, and you can't pass a validatable assertion about the user through that ingress system. And then you've also mentioned in the past, like egress filtering is also a thing in a lot of environments where you can't survive egressing your network without breaking TLS.
So is this, is this another layer on top of mutual TLS for like, okay, you have mutual TLS for service to service, but then, combined with that is a JOT that actually sort of says, well, now I have a live end user and this thing is short-termed. And
yeah, exactly.
I'm borrowing on how I know Google does some of this stuff internally. It may have changed, and there are different ways to skin the cat here, and I don't want to start spewing code names at everybody.
Yeah. So one key thing that we got from our identity team is that they don't want to support X509 because then they implicitly trust the front end, and they trust the front end to act as any user inside the identity domain of Google, right?
Okay, so they trust they trust the front end to authenticate any end user versus any service, because I think there's end user identity right, versus service identity. And
Well,
and
service
like,
identity doesn't go through the front end.
what's that? I'm sorry.
Service identity does not
Right.
does not the critical path does not involve the front end. So essentially, you'd say engine X, you terminate TLS. You're allowed to say that any user was on the other dialing end of this connection, and I must trust you.
One question I would have is when the audience is baked into the JOT, what audience, and you're expecting this to propagate through multiple layers, who would the audience be? Would it be the front end, or would it be the ultimate backend destination? And how would the client know the ultimate backend destination?
It would be the front end.
Okay.
So it would be the URL of the front end. So the backends would either need to suppose a backend was doing some data access, it would need to know in what context the request was issued for to validate audience.
Right, which in a TLS propagation scheme, it already is having to do, because it's having to verify via mutual TLS auth. You are the front end, and you're telling me this is Jordan.
Right. So this is
Jordan talking to the front end, which I can verify by the audience claim.
Right. This does not replace service-to-service communication. So the front end would still authenticate to the back end using whatever service-to-service communication scheme was put in place. This is purely a mechanism for propagating end user credentials.
Sure.
Okay, that puts it in a totally different realm in my mind. That seems like a layered thing. Like, because you have service-to-service authentication, and then you have, how do you now propagate end user identity across this stuff, which seems like it seems like these things should be layered on top of each other, and that wasn't clear, at least in my mind, from the way this was set up.
Yeah, I think with especially integrations with large companies with many customers, this is going to be preferable as the third-party integration, especially as since we can make these JOTs compliant with OIDC, the OIDC Select. So suppose a large provider like AWS or Google supports custom OIDC providers, then we can use these JOTs to authenticate as identities in those systems.
I don't know if that's true, right? Because the OIDC, this sort of proposal is talking about having two JWTs, whereas
right. So
both.
So to do the centrally issued JOT would be the JOT used for OIDC.
Yeah. Okay.
The second JOT, the individual integrator would have to support proof of possession key semantics. There's also the possibility that suppose a integrator did not implement this standard, then we could fall back to the central authority issuing short-lived JOTs. So that was the model one in the first doc. I think that is valuable in the interim while people want to ramp up and implement this standard, but it does have availability concerns pointed out.
So okay, so
previous discussions.
I got to be. I'm a little bit confused still, because the objective on the document says this document describes how to extend Kubernetes to support JOTs attesting to workload identity that are verifiable by third-party integrators. Mm-hmm. The discussion we just had wasn't about workload identity; it was about end user identity that is actually sort of transferable.
Yeah.
These workloads. So that seems like it's a totally different scenario. Now I understand that they may be connected, and there's like these things always get very messy, but the sort of justification for this that you just said and what's in the doc don't seem to line up to me.
From the perspective of Google Cloud, a workload running on Kubernetes on premise or in GCP or on GKE, that workload is the end user to Google Cloud Storage.
Okay, but from users of Kubernetes, the end user would be like, let's say that like we have like a hosted Heptio SaaS solution and we have people log in and maybe we're using Auth0 or something like that. That's the thing that's actually going to sort of identify end users. And so there's this question of like, okay, if we have a chain of microservices and we're passing around some sort of identity token for our end users, that's a different thing than talking to Google. And I don't want Google to know about my end users, right? There's no need.
Right. Yeah.
And similarly, there's securing the individual links in the chain of a call stack of microservices, and then also having the sort of some cryptographic identity of the end user being passed down, such that those seem like so it seems like we have three different scenarios. Then we have how do we actually identify through proxies to something like Google? How do we identify sort of links in the chain between services? And then how do we actually do true end users from the point of view of the application developer, right?
Right. So this targets the situation where Kubernetes is an identity provider. Individual workloads, individual service counts are identities provided by the Kubernetes identity provider, and a third party like Google Cloud Platform wants to authenticate identities from the Kubernetes identity provider. So this is the situation where the end users are Kubernetes workloads. I don't want to speak more generally than that.
Okay. So in some ways, this is a way to translate, say, a service account identity into a Kubernetes service account. into a GCP service account identity.
Right. Or
in generic size enough that it could apply to other things over time, right?
Yeah. So to give an example of the OIDC integration, are you guys familiar with the GCP identity, VM identity doc?
No. There's too many docs.
So you can curl the metadata server to get a JOT. You can curl a GCP metadata server to get a JOT signed by Google's OAuth authority. Now,
is there a way to mix in some sort of nonce or sort of other audience stuff into that JOT?
No, yeah, so you can request an audience. So if you had gone and set up OIDC provider in your AWS account, you could actually take that JOT and exchange it for AWS access token. That works today.
How does the OpenID Connect provider play into that?
So AWS offers configuration of custom OIDC providers. So you say this OIDC provider is allowed to issue identities under this namespace, which the namespace is the issuer URL.
Right.
So I could just curl the GC metadata server, exchange that transparently with AWS APIs if I have that configured in my AWS project.
Okay. And this is stronger than the AWS identity document because you can actually have it generate one for you with an audience in it, right?
Right. And I'm not sure how the AWS identity doc actually works. I don't know who signs it or if it's a OIDC compliant JOT token.
No, it's not a JOT. It's like its own, and it's mostly used, I think, to verify that, say, you're running a Red Hat image when you go and ask for Red Hat support, or when you're actually going through and talking to the Red Hat. So it's more along the lines of being able to identify, whether you're paying for a premium image, I believe. But it's been abused for other things, like as a attestation for things like Vault.
Right, but I do like that model. I think it's a model that makes a lot of sense and makes integration easy with third parties.
Okay, so this is. So you want something similar to the GCE metadata VM identity thing for Kubernetes service. Okay.
Can you talk a little bit about how you might actually implement this in like Kubernetes?
Yeah. So central issue model is really easy to implement. So I'll discuss the distributed model that is in the second doc. Essentially, a node agent would using, this is how I would prototype it. A node agent using the kubelet node credentials would request on behalf of a workload that long-lived jot. To create that request, it would have to generate a key pair. And it would hand both of those somehow to a workload, or it would keep them in escrow, and the workload could request short-lived proof of possession jots. So the combination of this long-lived jot and the proof of possession jot, where the long-lived jot is signed by the central authority, which could be an OIDC provider, and the short-lived jot is assigned by the proof of possession keys, the public key of which is claimed inside the confirmation field, a claim of the central authority issued jot. The combination of those presented to a third-party recipient would prove that the central authority vouches for the workload, and the workload possesses a key that the central authority has confirmed. So that's how the authentication works. The node agent would request those on behalf of the workload to a Kubernetes API. It could be a third-party API server, or it would use the kube aggregator framework initially for prototyping. We would turn off the service account admission controller, or we would potentially turn off the service account admission controller, or we would turn off the token controller so that service account tokens would no longer be generated per service account, and we would no longer generate the CA cert per service account. So we would have to deliver those through the node agent. So we would just remove those secrets.
Now, are we assuming that the communication between the workload and the node agent is an interactive API, or are we assuming that the node agent would lay some stuff on disk using like a flex volume or something?
It could go either way.
But if we're going to follow the GCP model, then you assume you have something kind of akin to the metadata server where you actually ask, so it's an active API.
I think that's a better model, but none of this stuff exists, so it's all open for discussion. In my opinion, that's the way I would go.
Yeah, like the two jots, the long-lived jot and then the short-lived jot. You see the short-lived jot also being issued by the node agent, not the workload directly.
Yes, either model would work, but I would like for the node agent to provide those to the workload, because we could keep the key in escrow in that situation.
Okay, so instead of using X509 certificate signing in chains, you're using essentially a jot to sign the public, you have the permanent jot essentially signs the public key. And then to verify that, you have to sort of call back to some sort of central server to validate that long-lived jot.
You don't have to call back. You have to have the public keys. So at some point in the past, I've had to obtain the public keys.
Okay, so that's essentially certificate signing. I mean, because you have one certificate that you trust that you use to validate a jot that actually says you should trust something
with expiration times. Yep.
It's a lot like actually like issuing a little intermediate CA that's scoped down to like a single identity, but with the wildcard for the audiences.
Yeah, I mean the benefits are the ability to target audiences, the ability to have more flexibility in claims, and the ability to propagate it through TLS termination, which is significant.
So, and you can also, depending on what you do with proof of possession, right, you can emulate like mutual TLS semantics if you validate the public key against the TLS public key.
Yeah,
right?
I mean, it's clever. I feel like it has the potential to be really useful. It also has the potential for us to like screw up replay and nonce and validation. So, I have to read through in detail. There are some things that appeal to me, like the ability for a workload to scope down a token. Right here, we're only talking about audience, but you could imagine scoping it in other ways, right?
But we would also be downscoping the expiration. So it would be reducing the expiration of the long-lived JOT.
Yeah.
Okay, so
Replay mitigations and things, are those standard, or is this just...
replay mitigation, there are a couple. JTI is one replay mitigation, but it is kind of a pain in the ass to implement from a distributed systems perspective.
it's like store some stuff. How hard could it be?
Right. Yeah, right. Take a stateless thing and make it stateful.
One way to do this, so there's two ways that you can divide proof of possessions into two ways. You can sign a request, or the server can encrypt a response. So if GCP IAM was returning responses using by encrypted with the public key as JWEs, then it would require possession of the private key to decrypt. And if those were held in escrow, then turning off the machine or turning off the TPM that stored those keys would make any JOTs that had been previously created useless. I don't know if that's exactly replay prevention, but it offers a lot of the same security
it's encapsulation
features.
Response.
Right.
All right, so Mike, let me summarize this, and you tell me if I've got this wrong. So the big advantages of doing something like this over traditional X509. The first thing is we're decoupling transport port from identity, so that's a good thing, right?
Right.
You have more flexible downscoping available to you, because we're not, you could technically do this stuff with X509, but practically it's a total pain in the butt to deal with ASN1 extensions and validation and all that. Most of the libraries don't support that, right? So we get much more flexible downscoping. And then there's OIDC compatibility here, so that you can interop for essentially presenting these things as proof to other systems. The big downside here in my mind, and other folks may have other stuff, is that there's just a lot of new code in crypto algorithms, and this stuff can be very subtle and error prone, because this stuff is pretty bleeding edge. Do you think I caught it fairly there, or is there stuff I'm missing?
Yes, I think those are fair. I'd have to think if there are any more pluses or minuses myself.
I will point out that it is likely, and in some cases already happening, that the current unscoped, unexpiring tokens are being used for things like this. And so...
Oh, well, we know that's happening with Vault, right? I mean...
Yeah. So, I mean, if you hold this up against like a perfectly implemented X509 system, there are downsides.
Oh, no, it's clearly better. It's clear. Well... It's better than what we have today.
It's probably better than what we have today.
Yeah. I mean, don't get me wrong. I'm not saying status quo is great.
Yeah.
Okay. So I mean, the one thing I want to say is that I don't want to speak for the other side. I'm looking at this also from the point of view of Spiffy. Spiffy, when I originally put the straw man out there on Spiffy, X509 was strictly a practical sort of thing here, and there was an idea that you could use the X509 for signing JOTs, but I think this also seems somewhat compatible with X509, right? I mean, with Spiffy, right? And I think moving towards a mode where there is an API between the workload and the agent to actually sort of negotiate what type of proof you want for which audience, that's something that is very much similar to the Spiffy workload API, or at least the stuff that we've been sketching out there. And for me, I like that a heck of a lot better than just laying down some static stuff on disk. So I don't think this is necessarily incompatible with at least the way that folks have been thinking about it. But I know that hasn't been something that has been front of mind for folks right now. So that's just a little sidebar there.
We need to work on how we reconcile these two models. I do think they serve different purposes. We would need different key pairs for client mutual TLS and JOT issuance.
So the other one, I mean, one big difference with mutual TLS versus this is the server side of the connection, authenticating a server, not just thinking about the clients authenticating. This doesn't really solve if you want to have an identity that you use as a server.
Right.
But we do have the problem right now, Moyer, with Kubernetes where there is no connection between the service that you're calling and the service account that the pods behind that service might have access to, right? So we still need a way to essentially say, hey, I'm a pod. I want to be able to get some certificate that can prove that I should be listening on this service, right? We don't have a solution there. The Google solution there is this thing called, what is it, like trusted? It's essentially sort of you augment the service discovery with the sort of the end credentials that you'll actually be talking to. So as part of service discovery, you get back from that sort of like, here's the identities of the things that you're going to be connecting to that are different from the service identity. Early on when we were talking Spiffy in that model, my opinion there is that breaks this facade that the service should prevent a unified front. And it works when you have sort of semi-trust, and you're not worried about knowledge leakage, but like in cases where you may not want those identities that are implementing the thing behind the scenes to actually leak out. So that's a little bit of a distraction there from what Mike has been saying here, though.
Yes, exactly. This is not useful for server authentication.
But what you could do is you could use this to authenticate yourself to something that would then give you a serving cert that actually says, hey, I'm allowed to actually talk as this.
Yeah, absolutely.
Yeah. So you could use this as identity to talk to a CA.
One comment on the replay thing. I was just thinking through that while you guys were talking. The encrypting the response using the nested public key works as long as the thing that's being done is you're concerned about read access, but if it's a write operation, then it doesn't protect against replay. So,
in the OIDC case, the response would be the access token. So, I absolutely agree with you.
Yeah.
I think I understand it better now, Mike. Thank you, even though I hadn't read the doc.
Yeah, sure. Well, if you get a chance, take a look.
I'll definitely dig into it. It's still on my list.
Similar to, I was tipped off, this is similar to how some of the Chrome OS authentication and IoT authentications work for Google IoT devices.
I mean, separating identity from transport layer is definitely a very nice thing.
Yeah.
So I also like here, like the centralized portion of this isn't involved in rotations, not the short-term rotations at all. So it's sort of only involved when you schedule a new workload, a new workload starts on a node.
Right. That's
but you still have the centralized control over like each individual node can only possibly issue tokens for workloads that are on that node. It doesn't have any powerful key that lets it issue arbitrary tokens.
Yeah, it's kind of there's, I don't know if you guys are familiar with chained HMAC caveats, where you can add caveats to a cookie. It's not well emulated in JWT, but this is something similar.
I was going to say, it does sound like macaroons.
Yeah, that's what I was going to say.
I think there's some support. I don't know how it works, but there's some support in macaroons for public key possession proofs chained into the macaroon.
Mm-hmm.
For something kind of like this, where you want a third party to assert identity of an entity.
I'll have to reread. It does make the JOTs a lot bigger.
Yeah, I mean, because you're going to have to pass through a chain of JOTs, right?
Just two in this model.
One thing that's kind of concerning to me is it's put a lot of the implementation pressure, a lot of the mistakes you can make are on the verifying side, which is code that might exist like in several languages. There's not going to be sort of one reference implementation of that.
So I would love to see if there is an API exposed to the workload, I'd love to see that API also offer verification services, because then that becomes a way to actually get a known good implementation for verification.
Yeah, I'd like to make the token review API support this eventually if it makes it into core. Or
Well,
actually, it could be webhook as well.
Even at the node agent level, like.
Yeah, that's what I'm saying. Yeah.
Right.
I think the node agent should offer token review.
That's definitely possible.
Because you're not going to want to go off host for token review all the time, if and you're going to want to do some caching and blah blah blah, right?
So if this is an interactive API, one of the weak spots we kind of identified in the container identity working group is there's not a good extension point in Kubelet for building a node agent that exposes like a network service into a pod's network namespace that in a way that lets you know the identity of the pod or the container. Do you see that same weakness, or does this get around that somehow?
I don't think I'm looking inwards, and there are certain situations where we do use network as an identity, but it's a lot easier because we run each one of our users as different Unix user, so we can actually inspect sockets. Since our users are crazy and run everything as root, I think I would prefer using a Unix domain socket and exposing a gRPC interface over UDS.
That makes sense. And that works with like flex volumes as the extension point in Kubernetes.
Right. So flex volume.
It also works outside of Kubernetes also, which is compatible with some of the spiffy goals.
Yeah, I expect flex volume driver would call to a central node agent, which would set up the directory in the spot where kubelet asks and maintain whatever material we want to maintain in there, whether it's UDS or key pair plus jot.
Putting the key pair plus jot there actually means that now we have to sort of worry about the security of the various libraries that people are going to be using to deal with these things. That seems like that's going to be.
Yeah, I think that's less preferable.
Yeah. Okay. Okay. I think we're clearly on the same page there. Okay.
So to get backwards compatibility with current service accounts, would you sort of take this model but pre-issue the kind of double jot and stick it in the known path? But
yeah,
with the audience of the API server.
Clayton had an idea about it. I would put it in the known path, and then I would have some service that deletes pods occasionally within the expiration of the. Well, how else would you do it? Our in-cluster config libraries do not reload jots.
So what I would do is I would have an annotation or some value on a pod saying, "Give me a forever token."
Right.
And I would make that be opt-in, and then I would actually update the client libraries to actually do it. So over time, at some point, people with new client libraries won't have to set that magic thing. I mean, you got to start deprecating it somehow. I mean, we went through, I think, about similar stuff with the GC metadata server around the sort of like, having to pass the extra header so that you could actually eliminate a bunch of proxy attacks. It just took for freaking ever to get new libraries to actually recognize that stuff.
Mm-hmm.
The nice thing, if we're talking about the service account jot, is it's only sort of Kubernetes clients that use it. So it's
except
easier.
for now it's
smaller.
not.
What's that? I think it's a smaller set of things to fix than if we were thinking of general like X509 rotation.
But it's not just, I mean, like with the Vault stuff now, other people are starting to use that thing. And I'm really afraid that use case will spread. So there is some urgency in getting something in place here.
We have a lot of control over what Vault does. So at this point, we still have control.
Wait, really?
Yes, definitely.
Okay.
We are in close communication with the
I've
Vault
sent
team
them suggestions.
implementing.
They've ignored me. Maybe they're paying attention to you.
Do you have better solutions for them? I think they're looking for a good solution.
All I asked is that they put some documentation in that thing saying that this thing is kind of very early quality and there's no issues with it, and like don't copy this pattern elsewhere, right? It's like some caveats there around like, look, this may work for Vault because we're going to trust Vault with the company jewels, don't copy this pattern elsewhere. Because I think a lot of people look at Vault, for good or ill, as a reference in terms of how you actually do certain types of cross-service authentication.
Integrators need a solution. A terrible solution is worse than no solution. So
I didn't tell them not to do it. I'm just like,
right.
please put some caveats there so that people don't copy them willy-nilly.
Okay, we
can forward you that.
This gives them a something to move on to that makes their integration secure.
All right. Any final comments on Mike Denise's proposal?
I'm going to try to begin to prototype this, and I will send you guys a link to the code when it starts to exist.
I would love to use this as an example on how maybe to run this stuff without having to build it into core Kubernetes. Now, some of the sticking points here are around aggregated API servers. If you start building it out that way, then it's hard to install that into things like GKE. But I think it's worth pushing on that.
Right now, the only API server that deals with this is the one that creates pods. So.
But he was talking about the JOT minting, the centralized JOT minter to be an aggregated API server, right, Mike?
Yeah. Also GKE supports aggregated API servers as long as they don't run on the master.
Right.
So you just put a link there. Can I ask you to rename that identity.kates.io? I mean, anything kates.io should be a reserved namespace. This is still very early work, and identity is a very broad brush on this.
That was the name of the API group. It is open to whatever, but I'm not planning on saying this is production ready or associated with the Kubernetes project. Eventually I would like to see this make it into
the description is Kubernetes identity. I'm just saying that you're kind of painting with a broad brush here. That's all.
I mean, it's not identity for anything else. Fine, I will rename it, but
I've been giving, every time I see an annotation that's part of a project that is not part of the Kubernetes thing, and they're using annotations and names that end with kates.io, I've been giving them crap. So it's not just you.
All right. What should the prefix be? .mikedenise.io?
Sure. Do you own .mikedenise.io, or should I register that now?
Don't defame me.
I'll see you in court. No, I just pick something, man. I mean, troutboard.com.
I'm definitely interested in prototyping this outside of core. I do see utility in eventually moving this into something that core provides.
So please make a trout board. I would think that would be awesome. That was the original dog food Gmail domain that Gmail ran on. Google still owns it.
All right.
It's awesome. Sorry.
So I agree. I would also like to see something like this eventually be in Kubernetes core as a default. That's always, if you're writing an application that runs on Kubernetes, it can rely on this mechanism. I don't think that necessarily means that it needs to be named with Kubernetes, because I think it's also something that could be available on other systems, not Kubernetes. It's like, like Spiffy.
And just to like tie up this conversation, is this something that the Container Identity Working Group is going to be discussing further and working to help implement?
I think it's very related, and I hope so.
Okay.
Yeah,
so,
a lot of the mechanisms, especially, are ones that other types of identity would want to do similar things with, and whether this becomes the bootstrap identity or another one, this sort of scoping and exchanging and injection based on the node's authority is right up the working group's alley.
Awesome. For anyone listening that that group meets this Friday at 8 a.m. Pacific. So if you want to discuss this further, then that would be a good place to do it. We don't have anything else on the discussion list. If anybody has any last-minute items, speak now or forever hold your peace. Okay.
I just want to say this is really interesting stuff, Mike. Thanks for driving it.
Yeah.
Sure, thank you.
I'm going to second that. Awesome. Well, thanks everybody, and we'll see you in 2 weeks.